Hello students, how are you? I hope you are doing well. Today I have come up with another video. I have picked three questions from mechanics. These questions were asked in the second shift of 25th January 2023 JEE mains. So without wasting time, let us jump to the first question. As you can see, consider a block of consider a block kept on an inclined plane. Angle of inclination is given as 45 degree as shown in the figure. Figure is there. Okay. This is the figure. This is the figure. Force is applied this way or this way. Okay. Force required to just push it up the plane incline is 2 times the force required to just prevent it from sliding down. Coefficient of friction is. Now coming to the first situation, the force required to push it up. So when the block is pushed up, let us say with a certain force, let us say F1, then the friction will try to oppose it. So friction will be acting in this direction, and as you know, the component of weight is already acting in the downward direction, which is mg cos 45 degree. The normal force is normal to the plane will be balanced by the component of weight this way. This is a free body diagram. Now for the equilibrium along the plane, we can write F1 must be mg by root 2 into small f. So total force up the plane must be equal to total force down the plane. Then coming to the next situation, as you can see, students, in the next situation, the block is just prevented from sliding down. So as you know, mg sin theta component tends to bring the block down. So naturally friction will oppose. So, but even though friction is acting up, it may not be adequate enough to stop the block from sliding. So in that case, this time the force is applied in like this. Okay. So you can see again, if we apply the condition of equilibrium, we have F is equal to mg by root 2 minus small f. This time I will take the force F2. Okay. So as per the question, you can see that F1 is 2 times of F2. So from the question we have been given that F1 is 2 times of F2, or mg by root 2 plus friction is equal to twice of mg by root 2 minus f. Now students, try to understand the situation. The block is on the verge of moving. Whenever a block is on the verge of moving, friction will be equal to the limiting friction. Very important. And the formula for limiting friction is nothing but mu into normal reaction. Since the forces perpendicular to the inclined plane will balance each other, so n will always be equal to mg by root 2. So here in this case, in both the situations, the friction will be limiting friction, which is equal to mu into n. So let us substitute that. Substituting for f equal to mu mg by root 2, f equal to mu mg by root 2, we can cancel mg by root 2, mg by root 2 gets cancelled throughout, and we are left with this 1 plus mu is equal to twice into 1 minus mu. So we have 3 mu is equal to 1, so mu is equal to 1 by 3. So 1 by 3 is 0.33. Then moving on to the next question, that is question 5. Students, the numbering of the questions have been done in a sequence. Okay. The first video has 3 questions. This is the second video. This also has 3 questions. This way, each video would be having either 2 or 3 or 4 questions depending on the nature of the questions. I have tried to segregate the questions based on the compatibility of the relative topics. Okay, if the topics match with each other, so I have picked up questions, keeping in mind that the each video does not carry more than 4 questions or less than 2 questions. So coming to the next question, a body of collision one mass, sorry, a body of mass 1 kg collides head-on elastically with a stationary body. So I'll draw the diagrams. Here in the first case, this is 1 kilo and this is 3 kg body. So this is at rest and this collides with a certain speed. Let us take it as u. Now after collision, what happens? The smaller body reverses its direction and moves with a speed 2 meters per second. The initial speed of the body before collision. Let us say that the final velocity of the second object is v. Let us say. Now in all the questions based on collisions, students, usually we have only two formulas. Only two formulas, mostly. 99% of the questions can be solved based on these two formulas. One is apply the law of conservation of momentum in the direction of motion and also perpendicular to the direction of motion. Here, there is no need to apply law of conservation of momentum perpendicular to the direction of motion because it is zero. So one condition you get from there. So when you apply law of conservation of momentum, you get one equation. The other equation is from Newton's experimental law, which states that relative velocity of separation after collision upon relative velocity of approach before collision is equal to E, where E is the coefficient of restitution, and coefficient of restitution, the value is decided by the nature of the collision. For perfectly elastic collision, it is E equal to 1, right? So applying law of conservation of momentum, we have 1 into u plus 0 is equal to minus 2 into 1 plus 3v. So this one equation, you have 3v minus u is equal to 2. Then Newton's experimental law states that relative velocity of separation is equal to E times relative velocity of approach. So relative velocity of separation, as you can see, it is v minus of minus 2. Coefficient of restitution is 1 for perfectly elastic collision. Relative velocity of approach is u minus 0. So the other equation is v minus u is equal to minus 2. This is the other equation. We have to find u. So what we can do is that we can substitute for v from here. We can substitute for v from here and solve it. So substituting, we have 3 times of v. What is v here? V will be u minus 2. So u minus 2 minus u is equal to 2. So u is equal to 3 to the 6. 2u is equal to 6 plus 2. 3u minus u is 2u, minus 6 goes that side. So u is equal to 4 meters per second. So 4 is the correct answer. I hope that is clear. Then moving to the next question, that is question number 6. A solid sphere of mass 5 kg and a disk of mass 4 kg have the same radius. Then the ratio of moment of inertia of the disk about a tangent in its plane to the moment of inertia of the sphere about its tangent. So students, one small piece of advice. Whenever you calculate the moment of inertia, you should notice the body as well as the axis of rotation. Because as the axis of rotation changes, the mass distribution of the body will change related to the axis, and accordingly moment of inertia will also change. So it's not adequate enough, for you to remember only the moment of inertia of the body. Also, you should remember the axis as well. Now, coming to this question, for a solid sphere, Mass is 5 kg. Moment of inertia of the disk. Moment of inertia of a disk. This is a disk about a tangent in its plane. This is a tangent. So about this axis we have to find. Now, since it does not pass to the center of mass, we don't have a formula directly. We cannot write it directly. So we have to consider the parallel axis theorem. So parallel axis theorem states that the moment of inertia of a body about any axis, let us write this as a dash. So moment of inertia about a dash is equal to the moment of inertia about a parallel centroidal axis plus mass into distance between the axis square. Now for the disk, it is m into, let us say, r square, where r is the radius, m r square by 4, whereas this will be m into r square. M is 4. So r square plus 4r square is equal to 5r square. Then coming to the next body, that is spherical body about a tangent. Same thing you will be applying again. What? Parallel axis theorem. As per parallel axis theorem, the moment of inertia, let us name the axis as B dash. B dash. So I dash is equal to moment of inertia of the body about a parallel centroidal axis plus mass into distance between the axis square. Here this will be 2 by 5 mr square. Remember, mass of the sphere is 5 kg. It is given as 5 kg plus m is 5 into smaller is same as capital R. So this we have 7r square. So the required ratio is this is to this. Okay, moment of inertia of the disk upon moment of inertia of the sphere. So you get the ratio as 5 is to 7. So x is how much? X is equal to 5. So that's all in this video, students. Thank you so much for watching my channel. Thank you.